All right, let's dive into what I like to call the alphabet soup of the Internet of Things. You know, NFC, BLE, LoRaWAN, 5G, it can get pretty confusing. But today, we're going to make sense of it all. We'll figure out how everything from your headphones to a city's power grid actually connects to the Internet. And you'll see there's one simple principle that explains why each one exists. I mean, have you ever really stopped to think about it? Your headphones are streaming crystal clear music, right? Your smart lights are just sitting there, sipping power, waiting for you to say the word. And that rental scooter you see on the corner, it's constantly telling its home base exactly where it is. How in the world do they all manage to phone home? Well, here's the big secret. They don't. It's not a one-size-fits-all deal. Each of these devices is speaking its own unique wireless language, one that's been perfectly tailored for the job it needs to do. It's all about picking the right tool for the right task. So let's start small, with the connections that are closest to us. We're talking about personal area networks, or PANs. The easiest way to think about this is as your own personal tech bubble, this invisible sphere of connectivity that follows you around wherever you go. First up is NFC, Near Field Communication. And this is for when things get really up close and personal. We're talking a range of like 10 centimeters. It's the magic behind tapping your phone or credit card to pay for coffee. In that tiny, tiny bubble, your device and the reader can safely and securely swap information. It's all about that close proximity. Now, for a slightly bigger bubble, we've got a technology we all know and love, Bluetooth. But did you know there are actually two main flavors? You've got your classic Bluetooth, and then you've got its super efficient cousin, Bluetooth Low Energy, or what you'll often see called BLE. And this is where it gets really interesting, because it's all about a trade-off. Classic Bluetooth, it's built for a constant, high-speed flow of data, perfect for your wireless headphones, but it's a bit of a power hog. BLE, on the other hand, is designed for tiny, quick bursts of information. Think about a fitness tracker that just needs to send your heart rate every few seconds. It just sips power, which lets these little devices run for months, sometimes even years, on a single coin cell battery. It gives up speed to win big on battery life. Okay, so what about RFID? The best way to think about RFID is as a super-powered barcode. You've got these little electronic tags, right? Each with a tiny chip and an antenna. You stick them on things, and when a reader sends out a radio signal, the tag just wakes up for a second and shouts back its unique ID. It's the secret sauce that makes tracking inventory in a giant warehouse actually possible. And this number right here, that tells you everything you need to know. The range is typically less than 10 meters, so it's perfect for scanning an item as it passes through a specific doorway or a checkout counter, but you're not going to be using it to track that same item across town. It's a short-range specialist. Of course, Bluetooth and RFID aren't the only players in your personal bubble. Especially in the smart home, you've got things like Zigbee, Z-Wave, and Thread. These create what are called mesh networks. Basically, it means your smart lock can talk to your smart light bulb, which then passes a message on to your smart speaker. They all work together to create this super reliable web of communication all through your house. Okay, let's zoom out. We're moving beyond our personal bubble and looking at the scale of an entire home, an office, maybe even a whole building. Our sphere of connectivity is getting bigger. Welcome to the world of local area networks, or LANs. And the undisputed king of the LAN is, you guessed it, Wi-Fi. It is the high-speed workhorse that connects our laptops, our phones, our TVs, pretty much everything, to the internet. It's built for one thing above all else, pumping out as much data as fast as possible. But just like with Bluetooth, that focus on speed makes standard Wi-Fi a terrible choice for a lot of simple IoT devices. It just uses way too much power. So Wi-Fi also has a specialized cousin designed to fix its biggest weaknesses. It's called Wi-Fi Hollow. So here's the deal. Regular Wi-Fi is a power-hungry beast built for speed. Wi-Fi Hollow completely flips that around. It trades away all that raw speed for nearly double the range and a much, much more power-friendly design. This makes it perfect for stuff like outdoor security cameras or sensors spread all over a farm. All right, now for something that sounds like it's straight out of a sci-fi movie. We've been talking about radio waves this whole time, but what if we could connect to the internet using the very light bulbs in our ceilings? This is what's called Li-Fi, or light fidelity. You feed data to a special LED bulb, and it starts to flicker at a speed so ridiculously fast that our eyes could never ever see it. But a little detector on your laptop or phone can see it, and it translates those flickers back into data. And the potential here is just, wow. We're talking about data speeds that could be up to 100 times faster than your Wi-Fi. Okay, time to zoom out one last time to the biggest scale of all. We've connected ourselves,
We've connected our homes and offices, but what about connecting devices across an entire city, or even across the whole planet? For that, we need wide area networks, or WANs.
Now, the WAN we're almost familiar with is, of course, the cellular network. It started out with 2G, which basically gave us digital voice and those first text messages. Then 4G came along and brought high-speed internet to our phones. And now we have 5G. And 5G is different. It's not just about faster movie downloads. It's designed from the ground up to connect a massive number of IoT devices with crazy speeds and almost zero lag. But even 5G can be total overkill for a simple sensor that just needs to send a tiny bit of data once a day. That's where this whole other class of technology comes into play: low power wide area networks, or LPWNs. These things are built to do one job and do it incredibly well: send tiny packets of data over huge distances. We're talking 5, 10, even 30 kilometers, all while using barely any power. And inside the world of LPWANs, you've got two big players with very different approaches to solving this problem: Sigfox and LoRaWAN. Let's see how they compare.
Here's a really simple way to think about this. Sigfox is like sending a tiny one-way text message. It uses this super narrow radio band to just whisper a tiny piece of information, like an alarm going off or a reading from a smart water meter. It's perfect for simple alerts. LoRaWAN, on the other hand, is more like a walkie-talkie. It's more flexible, it allows for two-way communication, which is exactly what you need for more complex stuff like controlling smart streetlights in a city.
Phew. Okay, so we have covered a ton of different technologies, from stuff that works in your pocket all the way to things that span the globe. So how on earth does anyone choose the right one? Well, it turns out it all comes down to pulling 3 different levers. And this is the single most important takeaway. There is no best technology. There is only the right tool for the job. Every single connection is a balancing act, a trade-off between these 3 things. How far does it need to go? How fast does it need to be? And how much power can it use? You can almost never have all 3. You want crazy speed and long range? Fine, but it's going to burn through your battery. You want amazing battery life and long range? Okay, but you're going to have to give up speed.
And this little cheat sheet really puts it all into perspective. You want to pay for something by just touching it? That's NFC. It trades away all its range to save on power. Want to track your steps all day? That's BLE, giving up speed for better battery life. Need to blanket your office in high-speed internet? That's Wi-Fi, which sacrifices low power for incredible speed. But if you need to monitor sensors on a farm a kilometer away, you'll reach for Wi-Fi Hollow or an LPWAN technology, because they happily sacrifice speed to get you that incredible range and power efficiency. See? Each one is a perfect solution for a very specific problem.
So we've kind of mapped out the connected world as it exists today. But the crazy thing is, the Internet of Things is really just getting started. As we move towards connecting literally everything, from the shoes on our feet to the very pavement in our cities, the need for new, more clever ways to solve that puzzle of range, speed, and power is only going to get more intense. And that leaves you with a really fascinating question to think about. What comes next?